So this is the last part of the tutorial in Module 1 in the first week. And just like before, make sure you have the folder available at hand. For Tutorial 1, in that folder you have already set up a project that's called Tutorial 1, and there are other documents that are related to this project that are located in the folder. So let's open the project. So it loads here. I have cleaned it up to remind you that one of the important things for us is to know which working directory we are, and it is in fact the folder that I have just checked where I have all the necessary information. I'm also going to open the script that we're working with in the first week. So if you downloaded script 1, you should have put it inside this folder. It's called script1.r. Because it has extension .r, it allows us to click here on the Open Folder button and open an existing file like that. And so here we go. This is script 1R. We can scroll down through the parts that we have already completed in the previous assignments. Let's say we stopped before, and this last tutorial is starts at line 183. Basically, so far we have worked with the files that were part of the package for training purposes, to give you a little bit of a sense of what you can do when you have a network object within R. But very often you produce or collect your own data sets that you then load into R and explore. And so for those purposes, you need to know how to read files into R and how to construct network from that. So this particular tutorial is very important for the assignment. So just to remind you, in the folder that I'm working on, I have also put a file called multigraphData.csv. That's the file that looks like that, and it's a file that I've downloaded from the edX interface because we'll be working with it. So we have checked the directory. The next thing that we can do is open the file. So we want to read an edge list. There are many different ways to do it. I have written here a line of code that's just one variation. And actually this is not the one that I use most often, but I thought that this could be useful for those who are just starting with R. So what we are going to do is we are going to run the command that will read a CSV file, and then inside this this line of code indicates that we will automatically choose the CSV file, and the header or the column names will be true. You can change it into false and see what the difference is to understand. But basically that CSV that I'm going just open in a second, I'm going to call it EL, which is short for edge list. Sometimes I would load a matrix, and so commonly I would call a matrix with a small m. So let's highlight the line of code I want to run and click on Run. And so automatically it pulls up a folder with which the project is associated, and asks me to select a file. So I'm selecting the file that's called multigraphData.csv because this is your homework assignment file, and this is the file that we're working with. And I select it and click Open. And so right now I have created an object. You can check right here in the right top corner, that's called EL. Let's just quickly look at what that object looks like. So on a Mac, when I highlight, I use a shortcut that's Control-Enter, but you could have just run this same line of code by clicking that button Run on the top. And so what this command does, to remind you, is that it just shows us the first several rows in the data set. So we can see that we have column names because we've selected header to be true, and otherwise we can see that there are 3 columns in the document. So it's a directed data set. Well, we know actually this is not a directed data set, it's a non-directed data set. So we're going to build a graph. But before we do that, you see how here we have 1 to 81 and type partners? What that data set represents, and you can read the description of the data set on the edX platform, is that we basically have a tie that goes from something that's labeled with ID 1 to something that's labeled with ID 81, and that tie is a type of partner. So in this case, it's partners doing homework. We also know that person 1, because here we're dealing with students, and person 81 have a tie because they were doing homework at the same time. But these 1 and 81, they are not numbers that we will be doing any mathematical or arithmetical calculations on. And so not to confuse R, it may be useful to treat them as characters. This is more of a housekeeping piece of work at this stage. That's how I would explain it. But it's important because if we don't take care of treating the variables as not numbers, we may accidentally have problems later on. So what I'm doing here is I'm highlighting and telling R that the first column should be character. I highlight and run it. And the second column should also be treated as characters, not as numbers. Then, in order to convert this edge list into a network object, we're gonna create a matrix. In this case, it's not an adjacency matrix, but just a matrix class of R. So if I highlight that, basically what this line of command says create the object called M. And that object is going to be object edge list, only first 2 columns, and treat it as matrix. So if I run this and I put head M, you see that now this same data set looks slightly different. So we only have the way it's documented is different. So if you want to understand these differences better, you can read up or you swirl or go back to the previous MOOC on fundamentals of learning analytics to figure out the differences between a data frame and a matrix. So this is not an adjacency matrix, but it's a matrix class in R. It's required because the next line shows us how we can make a graph. And so command graph edge list can only be run over matrix class. That's why we had to convert it. So we're going to run graph edge list over M, and we're going to specify that we're building an undirected network, so directed is false. Just to remind you, every time you want to know more about a command, you just put a question mark and a command function. Right, and it's probably not going to work because I haven't done, well, let's try. This shouldn't work. Right. R can't find function. Does it mean that something's wrong? Well, not really. All it means is that because I am working with the new I just opened this from scratch, I didn't load my packages, so I need to load iGraph so that now if I want to retrieve that command, that should work. Right. So now iGraph has been loaded and we can check those commands that are a part of functions that are a part of the iGraph dataset. So we can now safely run graph edge list over our created matrix to create an object G. Well, we may want to check object G out, and fair enough, it's an undirected network with 185 nodes and 360 edges, and we can read a little bit more. And we can see that this network has no tie attributes. So, well, of course, because we have created it from the matrix that looked like this, and it had absolutely no information about the ties. So this is when we assign the type. If you remember, we started by importing the edge list. that had the third column. So now we're going to assign a type to an edge of the network G, and that type is going to be equal to the third column of the object EL, or edge list, that this guy here, and it's going to be treated as character. So I'm going to run that, and now if I reproduce this command, we're going to see that here we go, we have an edge type. We can also check out, we can count, because we know that the type has different categories within it. So one of the simple way of doing it is using table. You can check what table means by putting a question mark here, and it says that it's builds a contingency tables of the counts of each combination. What is a contingency table? Well, let's run this table command over the vector of all types, of all edge types. And so what it does, it counts each of the separate categories, just the number of times that appears in the vector, which in our case is the list of different edge types. So we can see that most of the students were partners, and that very few students were using the same computer, and some sort of 97 people were doing homework at the same time. The next thing we need to do is to load the demographic data. So here I created, you just need to reproduce this for now to make things less complicated. I'm going to read a data file that I've created with fake demographics about those students, and we're going to call that file names. So just highlight that, and you can look at what that object looks like. I could have had this information in a CSV, and then I would have needed to load the CSV into the studio, into the RStudio, which you could do as well, but we are going to use reproducible data here because it's a part of your assignment, and I would like you to be able to understand the range of things. But it's normal that something may not work the first time you're going to be trying to create nodes object from a CSV rather than using an R data if you do that. In any case, we created a node list. First, let's look at the column names of it. And we can see that it has 4 column names. So we have fake names of the students. We know whether they're boys or girls. We know what their grades are. We know what is the level of education of their parents. And we also have just a numeric ID of the students. And I'll explain why the numeric ID is important. There is a relationship between your node list and your edge list, because these numbers here, we remember the ties. So for instance, the first tie in a network from 1 to 81 is not really from number to number, but it is from the person who has ID 1 to the person who has ID 81. And so what we need to do right now is we need to match this information, these names of students, to the vertices in the network. And we need to do it in a way that's not going to just match them by order, but it's going to match them based on the vector called ID. So if this is too confusing, I recommend just copying this line and then trying to read through it again, as we're going to do it again and again. And I tried writing out the explanation here. But basically what we're going to do, let me just run this first one. I'll explain in a second. What that does is that it creates, if we put now the network information, we have just created an attribute called name for vertex, each of the vertices in network G. How are we creating it? We're creating it by matching the name, which is 1, 2, 3, 4, 5, etc., of the vertices, as in ties, to the ID in the nodes data set, and we are giving it a few more specifications. So now we're going to repeat the same, and we're going to match our demographic sheet with information about gender, grade, and education to the vertices again. So let me go over another line of code here. We are going to create a variable for a variable called sex, and that's going to be an attribute for each of the vertices in network G. The content, the value of each of the cell of this variable is going to be the same as the variable in the vector sex in the data frame nodes, which is nodes and sex. So this is this vector. We're going to take this vector and make it into a vertex attribute within the network. And to do that, we're going to match the vertex name, which is 1, 2, 3, 4, 5 within the network, to the node's ID, which is 1, 2, 3, 4, 5 within the node list. Okay, so we run this command again, and if I run request the information about the network, you can see that we have created a new vector. So I repeat the same for the grade, and you can see that here I changed something. So instead of asking it to be as character, I asked it to be numeric, because the grade is numeric and I may want to do some calculations with it, so I don't want it to be treated as character or as factor. But I do not care much about the education, so I'll just run it as is. This may be, so you can see that all of these things are here. It may be important if you want to export the network, or if you want to do some statistical analysis, because now you can basically export the data frame with nodes, much like we did in the previous tutorial, or calculate degree and look whether degree correlates with the grade, for instance, in using statistical software. And so the last part of the tutorial is to show you how we can calculate different centralities looking at the networks that are already a part of this data set. If you remember, we have loaded an edge list that had different types of ties. So what if we want to look at the network of just partners? So for that purpose, we can create a network of people who are sharing the computer, right? So for this purpose, we can create an object that's called gcomp, or network of those who share a computer. And to create it, we're going to run a command subgraph edges over our graph called G. And we're going to create a subgraph based on the particular type of edges that equals computer. So the text of the tie type should be computer, and we want to delete all the other vertices. So if I run this command, and then I want to look up information about gcomp, I can see that now it's an undirected network, but it's clearly a subgraph. It's smaller than our previous network. I may want to plot it because it's small. It's possible that I will be able to see something. So we can see that there's a little 4-node piece here, 3-node piece here. So these are the students who shared the same computer. We can play a little bit with color, so I can show you how to do that. For that, you would create a color, an attribute of the vertex called color, and that's going to be the same, for instance, as we're going to equal it to the attribute called sex. And then we are going to replace everything that says female in yellow. And then we're going to replace everything that says male in green. And then we're going to plot this network without plotting the labels of the vertices, using a particular type of layout. And here we go. So we can see that, well, there's quite a bit of homophily in the network. What is homophily? You're going to learn in the next module. But basically here, a lot of boys and girls seem to be sharing computer. Well, we don't know what that means just yet, so it's quite difficult to interpret that. We could also choose to plot the label by name of the vertices, and here we go, we can see their names. One of the tasks that you'll have to do in your homework would be to calculate degree of the subnetwork. So to do that, it replicates some of the information of previous tutorials. So we create a vertex vector that calculates the degree of the subnetwork. We could also ask to do the same for the betweenness. Remember to specify that the network is not directed. And then we want to create an object called attributes that gets vertex attributes of this network. And I'm just going to use view attributes to check that out quickly. And you can see here we are. Here we go. We have this data set. Betweenness is, we can see the degrees and betweenness, and we can see top students because we can press on the degree and sort it out manually. We can also just run the gcomp to see the information about the network. We can use edges density as we have done that in the past. It doesn't want to do that. And so I just figured out that it doesn't want to do it because I had a mistake in the script that says edges density, and that command doesn't exist. So if we run edge density, then we get a number that says 0.03, which is the density of the edges of the subgraph that we derived by subsetting the network of homework partners to people who shared the computer, and running command over it. We can also calculate the centralization of the network, and that's how you would do it. And that is pretty much all you need to know in the first week of how to use R for network analysis.